Good morning, students. Once again, I welcome you to my video lectures on signals and systems. And in this chapter, LTI chapter, that is linear time invariant systems, I am continuing with convolution convolution integral between continuous time aperiodic functions. And already two problems are over. And you might have observed one point. Actually, in this type of coaching, I can't expect answer from you. But in the class in my college, had I questioned students, they would have answered. In the previous examples, two examples I have solved so far. Each waveform was having only one edge. Each waveform was having only one edge, because the other one was to proceed towards infinity. Whenever the waveform goes towards infinity or goes towards zero at t equal to infinity, they cannot have both edges. So whereas here in the coming examples, I will take up waveforms with two edges. Now this is the third example. Convolution between this function and step function. Already step function is familiar. And this function, see here I have shown e power minus t ut. In the previous examples also I took e power minus t ut, but the graph was extended from 0 to infinity. But here I have taken only a part of the graph. That is, only in the interval 1 and 2, the function is e power minus t ut. For the rest of the time, it is 0. It is 0. Here also 0. Here. That means the waveform is like this. So, two edges. There are two edges. Now, it is more interesting to solve problem with both the edges. So, first I will take up this waveform to be stationary waveform and this to be the moving waveform. If you write a mathematical equation for this, you refer to my earlier lectures. That is very in the beginning, as soon as I started this video lecture, in the lecture class number 2 or 3, I have taken up gate function. So using gate function, one can write this equation. Xt is written as, so only between 1 and 2 the function exists. Therefore, xt is e power minus t ut u of t minus 1 minus u of t minus 2. This is what is called as gate function. Now you need not have to know about gate function, but in the examination, suppose if picture is not given, if the waveform is not given, but if mathematical form is given, you should be knowing this to sketch. That is why now I am stressing gate function for you. So e power minus t ut u of t minus 1 minus u minus 2. For the problem it is not required. This is xt. Whereas ht is, as you know, that it is a step function, unit step function, u of t. Now as usual procedure, first replace t by tau. Now here what I will do now, I will make this x of tau. Then this becomes tau. This is also h of tau. This is also tau. Now sketch first the stationary waveform. Sketch the stationary waveform. The stationary waveform is here. Between 1 and 2. E power minus tau u tau. Because you have to change t to tau. This is x of tau. Now, what is the procedure? How to get h of t minus tau? Now I have to get from this graph, I have to get h of t minus tau. To get h of t minus tau, as I said, first take mirror image. Take mirror image. Reflection. Suppose on this side also if the waveform is there, it comes to this side, and the waveform on this side comes to this side. That is reflection. So take a mirror image of this. After taking the mirror image, you shift by t units. T plus t means it is to the left. It is to the left. So by how many units? T units. Then you will going to get h of t minus tau. Now I will sketch h of t minus tau. H of t minus tau. Now at the time of reflection, this waveform was here and it was shifted by t units. That is why this edge will be t edge. This edge will be t edge because it is shifted. Because earlier it was here. Because at the time of reflection it was here. Because if you take the mirror image of this, it will be like this. Then you will going to shift by t units. Therefore, earlier it was at 0. Now if you shift it by t units, it is called as t edge. It is called as t edge. Now, that is why now this is called as t edge. This is the leading edge. This is the leading edge. There is no other edge. There is no. But for this waveform, there are two edges. Now, one has to think of moving this waveform this way. This way. You look into the figure. If you look into the figure, when overlap starts, if overlap has to start, this edge must approach here. Even if it approaches origin, it is not going to overlap. Then it has to reach t equal to 1 here. It has to come this way. Now you will have an idea now. That means for this t less than 1, for t less than 1, there is no overlapping. No overlapping. OL stands for overlapping. So for t less than 1, no over. This is one interval. So in the last class I told about intervals. So number of intervals in a problem, you will come to know if you practice more and more problems. So in this problem I will tell you how many intervals come. This is one interval for t less than 1. That means from minus infinity to 1. So when you sketch yt graph, there is no overlap. Therefore, what is yt? Yt is 0. Yt is 0. This is one of the answers. Yt equal to 0. Now, if overlapping has to start, now this edge must come here. And here must come here. Now t edge is here. And if overlap has to start, t must be greater than or equal to 1. T must be greater than or equal to 1. Less than 1 side, greater than or equal to 1 other side. Therefore, here I will show some portion of a step function here, and this is overlap. And that means overlap has started. Overlap has started. I have shown by hatched lines. Overlap has started. Now you should be in your mind, how long should I move this step waveform? So next interval. As this has got infinite width, but this has got width of only 1. Because this is 2, this is 1. 2 minus 1 means 1. This exponential form has got a width of 1 unit. Therefore, you have to advance this up to here. That is, t greater than or equal to 1 and t edge less than 2. T less than 2. That means up to 2. So this is what is called as interval. So you have to correctly, in the examination, you have marks for interval also. Not only YT answer, but also interval. You have some marks. Therefore, I will combine these two and I will write the range. The range is 1 less than or equal to t less than. So while writing the ranges, continuity should be there. Previously t was less than 1. So after t less than 1, now it has started with t greater than or equal to 1 and up to t less than 2. And finally this edge will be here. I will show that. Now calculate the convolution. The convolution is y of t is equal to now product form. First write product form. The product form means this is e power minus tau. U tau is 1. You need not have to worry. U tau value is 1. Forget about u tau. Or let it be there. Then what is the value of this 1? Step function 1 into 1. d tau. Now interval. Now overlapping has started. With t equal to 1 and th. Therefore, here you write 1 and t. So 1 and t it has started and it will go up to 2. That is taken care here. T less than 2. So here integrate. On doing integration minus e power minus t 1 to t. That is minus e power minus t minus e power minus 1. That is 1 by e minus e power minus t. Now in this problem it is very difficult to sketch this. So just write the expression. Okay, this is yt. This is yt between one edge and t. 1 and t. Now you show the end. So now earlier what the waveform was here. Now the waveform comes here. Now the waveform comes here. The waveforms comes here. Now for this edge, as it crosses 2, there is no waveform here, 0. Because there is no overlapping. There is no overlapping for this edge. But for the rest of the waveform, it is still overlapping here. Entire exponential waveform is being covered. You imagine in the eclipse, the moon is fully covered with shadow. Okay, fully covered. That means for that fully, you how to write the integral is the question. Before that, first interval. Mark the interval. I will mark the interval here. It was over 1 less than or equal to t less than 2. Now t greater than or equal to 2. T greater than or equal to 2. Then how long should I take? Even if it goes to the other end, that is t equal to infinity, still it will be fully covering this waveform, because it is this side also it is coming from minus infinity. Therefore, and t less than infinity. Combine these two. If you combine these two, 2 less than or equal to t less than infinity. Compare. Previous region interval was over with 2 less than 2. Now it has continued with 2 less than or equal to t less than infinity. Continuity should be there. If continuity is not there, that means interval is wrong. Now continuity is there. So next, calculate the integral. Now at the time of calculating the integral, limits must be taken 1 and 2. Limits must be taken 1 and 2. You may question why you are not taking the edge. Because edge has passed off. Edge has passed down. Now edge has come here. It has come out of the waveform. When it has come out of the waveform, I can't show overlapping. But the rest of the waveform, there is overlapping here between the edge t equal to 1 and t equal to 2. Therefore, in the interval, you write 1 and 2, 1 and 2. Then mathematical form of the functions. As usual, e power minus tau into 1 d2. E power minus tau into 1. That is minus e power minus tau limit 1 and 2. That is minus e power minus 2 minus e power minus 1. That is 1 by e minus 1 by e squared. This is answer. This is the answer. So, for t less than 1, yt equal to 0. First answer. Second answer, for 1 less than or equal to t less than 2, it is 1 by e minus e power minus t. 1 e t. Then yt is equal to 1 by e minus 1 by e squared. That is a constant. This is a constant term. This is a constant term. Whereas this is an exponential term because there is some variable t. So it's very difficult to sketch this. So nobody expect you to write, to sketch the graph. So leave that. So just write mathematical expression. See one thing. So I request students who first correctly write the range. Ranges are very important. After writing the ranges correctly, for each range, that is interval, you correctly write yt. So integration. So integration doesn't bother you, but because you must know, if you are a diploma holder, please try to remember few integral formulas for exponential or for such simple waveforms for t. So this is the problem. Now in the next work example, I will reverse the order. So I will take this to be stationary waveform, and I will take this to be the moving waveform. Okay? Thank you.